Hello friends. This video is brought to you by mywayteaching.com.
Work done against gravity. The force of gravity of Earth pulls everything toward the surface of Earth. For example, if we lift the book from a table, we do work against the force of gravity. That means when a body is lifted vertically upwards, then the force required to lift the body is equal to its weight. That means whenever work is done against gravity, the amount of work done is equal to the product of weight of the body and the vertical distance through which the body is lifted. Suppose a body of mass m is lifted vertically upward through a distance h. In this case, the force required to lift the body will be equal to the weight of the body, that means m into g, where m is the mass, g is acceleration due to the gravity. So work done in the lifting a body equal to the weight of the body into vertical distance. That means work done in lifting a body, that means W, equal to weight of the body, that means m into g, and vertical distance means h. So where m is the mass of the book or a body, g is acceleration due to the gravity, h is height through which the body is lifted. Now this formula, that is W equal to mgh, we will use this formula to calculate the work done in all those cases where the object is being lifted upward against the force of gravity. Now on the screen, a man of mass m climbing the stair having a vertical height h. In this case, the work done by the man in lifting his body upward against the force of gravity of Earth, that is mgh. Now let us take another example. Now in the screen, the book, in lifting the books from floor, this man is doing work against the gravity. Now let us take one more example. In this diagram or picture, in lifting the weight, this weightlifter is doing work against gravity. Now let us read the question. How much work is done by a force of 10 Newton in moving an object through a distance of 1 meter in the direction of force? So our formula is W equal to F into S. So the force, it is given as 10 Newton. The question, distance S equal to 1 meter. So the total work done is equal to 10 into 1, and the unit of the work done is joule. So the total is 10 joule. Thus the work done is 10 joules. Now let us read the question. Calculate the work done in lifting 200 kg of water through a vertical height of a 6 meter and assume g equal to 10 meter per second square. So the solution is, In this case, work is being done against gravity in lifting water. Now the formula for calculating the work done against gravity is W equal to M into G into H, and here mass of water is 200 kg and G that is given in the question is 10 meter per second square. You can write like this way, or you can write meter per second square, and height is 6 meter. Now putting this value in the formula, what is the formula? The formula is W equal to mgh. So W equal to M is 200 kg, G equal to 10 meter per second square, H equal to 6. So it comes 12,000 joules. The unit of the work done is joules. So the work done is 12,000 joules, or there is 12 kilojoule. Now read the question. A car weighing 1000 kg and traveling at 30 meter per second stop at a distance of 50 meter, decelerating uniformly. What is the force exerted on it by the brakes? What is the work done by the brakes? Here the solution is, in order to calculate the force, we have find out the acceleration, or we can say it's a retardation. So the initial speed that is 30 meter per second. It is given in the question, and the final speed, what is the final speed? It stops, so that means V equal to 0 meter per second. Now we have to find out the acceleration or retardation, and we know that the distance that means S equal to 50 meter, and we know that V square equal to U square plus 2AS. V square equal to 0 square, U is 30 and 2A is not given, then 50. So 100 A to minus 900. What we have done? This 2A into 50 is 100 A, and 30 square is minus 900. So and this is 0, so we taken this 2 here, so this is 2a and 50. So now again it's a 2a, 50 is 100a equal to 30 square is minus 900, because we shift from left to right. Now so a equal to 200 cancels, so that means minus 9 meter per second square. What is the unit for the acceleration? Is meter per second square. So the force exerted by the brakes can now be calculated by which formula? We know that F equal to m into a. So the mass in the question is given at 1000 kg, and acceleration what we have calculated, that is 9 meter per second square. So the force is 1000 into minus 9, that means minus 9000. What is the unit of the force? That is Newton. Now what is the meaning of this negative sign? Negative sign means the force exerted by the brake on the car is 9000 newtons. The negative sign shows that it is a retarding force. So the work done by the brakes can be calculated by using this formula, W equal to F into S. Now we know that this work done is a scalar quantity. So the force is, we have calculated 9000 Newton, and what is the distance? Distance is 50 meter. So the total work done is 9000 into 50. So 9 into 5, 45. 45, how many zeros? 3 plus 1, 4 0. That is joules. So we can also write that work done is 4.5 into 10 की 5 joules. How we have taken this? 40 and point, so we put point here, so the 4.5 into 10 की 5 joules. So the total work done by the brake is 4.5 into 10 की 5 joules.